Today's busy veterinary care environment, pet owners often struggle with managing their pet's health appointment due to tight schedules, urgent medical needs, and limited clinic availability. Veterinary clinics offer various services from vaccination to surgery, but managing this manually can lead to inefficiency, scheduling conflicts, and unfair handling of walk-in patients. To address this challenge, we developed the VetCare Patient Management System, which is VPS. This system is designed to streamline appointment booking, rescheduling, and cancellation, managing walk-in patient fairly using a queue system. Provide veterinarians with an organized platform to track patient records and schedules, improve clinic efficiency, and service accessibility.
Next, this is a sample of the input file named petinfo.txt. The file contains pet appointments data that will be read by the system. Next, we will look at the coding used to process this file. So the system will display a menu containing 8 choices. So the user needs to select one option to proceed with the system. If the user chooses choices number 1, which is to display all pet appointments records in the linked list, so first, the system will print the table header using the printf, so the output will be aligned and easy to read. And after that, the system will retrieve the first element from the linked list using the get first. And after that, we use while loop to retrieve the data, and if and the looping will continue if the data is not null, which is there are still records in the list. So each object retrieved is cast into a pet object so that the pet details can be accessed to using the getter method. So the pet information such as pet ID, name, and more can be displayed in formatted table. After display one record, get next method is called to move to the next nodes in the linked list until all records have been displayed. Is to search a pet appointment using the pet ID. First, the user is prompted to enter the pet ID, and after that, the system will traverse the linked list from the first node using the get first method. And after that, for each pet object, a pet ID is compared to the user input just now using the equal ignore case. If the matching pet ID is found, the system will display a full detail of that pet and set the found is equal to true and stop the loop using break. And after this, the system finish the traversing the list using the get next. If the the pet ID is not found, the system will display pet not found. It is to cancel a pet appointment based on the pet ID. First of all, the user must enter the pet ID to cancel, and the system will traverse the original linked list, which is the pet list, from the first node. And after that, we need to make a new linked list we call as temp list, also known as temporarily linked list. It is because if the pet ID is matches with the user input just now, the appointment is considered as cancelled and is not added to the temp list. However, if the pet ID is not matches, the pet object is added to the temp list. After the traversal is complete, the original linked list is emptied, and then all the data from the temp list will be inserted back into the pet list. However, if no pet ID matching is found, the system will display pet not found.
Next, I will explain the system function for updating pet records, registering new pets, and managing walk-in patients. For choice 4, this function allows the user to update an existing pet appointment information. First, the system asks the user to enter the pet ID that they want to update. The program then traverses the linked list to search for a matching pet ID. So once the pet ID is found, the system allows the user to update several details such as illness description, vaccination status, appointment date, and appointment slot. As for vaccination status, the program only accepts 1 for vaccinated and 0 for not vaccinated, which help ensure valid input. For the appointment slot, input validation is applied so that only M for morning, A for afternoon, or E for evening is accepted. After all updates are completed, the system displays a confirmation message to indicate that the appointment has been updated successfully. If the pet ID is not found in the linked list, the system will inform the user. So next is choice 5. This part of the code is used to register a new pet with a scheduled appointment. The system first collects the pet's details such as pet ID, pet name, species, and age, and owner information such as owner name and owner phone. Next, the user is required to enter the illness description and vaccination status. Vaccination status input is validated so that only 1 or 0 is accepted, preventing from incorrect data. The system then asks for the appointment date and time slot, where only M, A, or E is allowed. After all required information is entered, a new pet object is created. This pet object is then inserted at the back of the linked list, storing it as a scheduled appointment. Finally, the system confirms that new pet has been registered successfully. So next is choice 6. For choice 6, this function handles walk-in patient using a queue data structure. The system collects similar information as scheduled appointment, such as pet name, pet ID, species, age, owner name, owner phone, and illness, and vaccination status. However, instead of assigning an appointment date and time slot, the appointment type is set as walk-in and the slot is marked as W. The pet object is then added to walk-in queue using the enqueue method, and since queue follows the first in first out principle, walk-in patients are served fairly based on their arrival order. The system then displays a message to confirm that the walk-in pet has been added to waiting queue.
Next, for the choice number 7, which is to display all pets currently in the walk-in waiting queue. First of all, the system needs to check whether the queue is empty or not using the isEmpty method. If the queue is empty, the system will print message no pet is in the waiting queue. However, if the queue is not empty, the system will print the table header to format the output neatly. And after that, the temporary queue is created that called temp. This is done to ensure the original queue order is not lost. And after that, the system will enter the loop where each pad is removed from the front of the queue using the D queue. And after that, the object is cast into a pad object so that the pad's detail can be displayed. Last but not least, the pad is added into the temporary queue using the enqueue method. After all the pad has been displayed, another loop is used to move all the data back from the temporary queue into the original queue, which is walk-in queue.
Final option is for option number 8 is the exit command. Before closing, we want to provide a summary of all shader records. First, we print a header with formatted columns like ID, names, and illness to ensure the output looks like a professional report. To show all the data, we start at the very beginning of our linked list by calling our getFirst method. So after that, we use a while loop to traverse the list. This loop will keep running as long as there is a next node to read. Um, Inside the loop, we cast the generate object back into a pad object so we can access its specific attribute like age or species. This from the system.out.println p.getID will we print the details of the current pad in the formatted row. Crucially, we move the next node in the list. This prevents an infinity loop and ensures we visit every pad in the system. Finally, once the list is fully printed, we use system.exit to safely terminate the program.
Now, let's see the output produced by the system.
Our VetCare patient management system solves real veterinary clinic challenge, managing pet records, appointments, and walk-in efficiently. We have created an organized, user-friendly system that improves daily operations through structured data and a simple menu interface. Technically, we use a linked list for flexible appointment management, a QFIFO for fair walk-in patient handling, clean OOP design for easy maintenance and future growth. We overcome key challenge in linked list logic and input validation, gaining deeper Java skills and learning the value of systematic debugging and teamwork. VPS successfully meet all objectives for fair patient management and has a strong foundation ready for real-world expansion into billing or medical history modules. Thank you. That concludes our presentation.